So today we are going to do our group assignment project for mathematics engineering. So our assignment is to solve the integration problems. So my name is Nur Izzati Dewi Binti Rashid. My matrix number is 202790.
My name is Natasha Fitri Binti Salaman and my matrix number is 203718.
Okay, so now we're going to solve the problem.
Okay, so today the equation we want to solve is integral of x power of 3 over square root of x squared plus 9. From the further trigonometric integral, x squared plus 9 square root can be simplified as x squared plus a squared. A squared equals to 9, then a is 3. So from this equation, we can simplify as a tangent theta. So the equation will be x equals to 3 tangent theta. We differentiate the x, will become dx over d theta equals to 3 secant square theta. We make the dx as subject. Dx equals to 3 secant square theta d theta. Then we substitute the dx into the equation and the x to the equation. So it will be x 3 tangent theta power of 3 over x squared would be 3 tangent theta square plus 9. Dx would be 3 secant square theta d theta. So we expand the bracket, would be 27 tangent cube theta over square root 9 tangent square theta plus 9 3 secant square theta d theta. So the denominator we can simplify as 27 tangent cube theta over 9 tangent square theta plus 1 3 secant square theta d theta. As we know, tangent square theta plus 1 equals to secant square theta. So we substitute the tangent square theta plus 1 equals to secant square. So it would become 27 tangent cube theta over 9 secant square theta 3 secant square theta d theta. Then we solve, become 27 tangent 3 theta 3 secant square theta 3 secant square theta d theta. Can simplify 9 tangent cube theta 3 secant square theta d theta over secant square theta. Become 9 tangent cube theta 3 secant square theta d theta over secant. So we can simplify this one become 27 tangent cube theta secant theta. Simplify the tangent cube theta will be tangent theta tangent square theta secant square theta d theta. 27 tangent theta secant square theta minus 1 secant square d theta. So from the equation, we can let the secant theta equals to u. Then we differentiate the secant theta, will become tangent theta secant theta du over d theta. So make the du as the subject. Du equals to tan theta secant theta d theta.
So now we are going to continue what Tasha left, which is the equation of 27 tan theta secant square theta minus 1 and secant theta d theta. So based on what Tasha do, which is let u the secant theta, and from there you can get d tan theta and secant theta equals to du d theta, which is mean du when you bringing the d theta there to the left, so we get du equals to tan theta secant theta and d theta. So from here you can simplify the equation to be 27 u square minus 1 du. Okay, from here you can continue to integrate like normally, which is 27. We bring it outside and you integrate the inside part only, which is going to be 27 u cube over 3 minus u. Okay, from there you can substitute back the secant theta back inside, so it will be 27 secant cube theta over 3 minus secant theta. Okay, from here you can cancel out the 3 and 27, which is we get 9 and 1. So now we are going to left with 9 secant cube theta minus 27 secant theta. Okay, to clear this up, this is actually getting from the expanse of the equation, which is going to be like 27 secant cube theta over 3 minus 27 of secant theta, which is you can cancel out the 27 and 1, which is going to be 9. So it's going to be the same thing as well. So 9 secant cube theta minus 27 secant theta, which is the same like this one. Okay, now we are going to continue with the integration as well. However, we are going to need the final answer in x, which is we need to integrate this in using the triangle, which is trigonometry, which is going to be this one, but we are going to refer back to what Tasha did before, which is this equation, which is we are going to bring back here, which is going to be x equals to tan 3 tan theta. Okay, so from here this is the theta, so tan going to be tan theta going to be x over 3, correct? Tan is opposite over adjacent, so the opposite going to be x and this is going to be 3, and then the hypotenuse would be x squared plus 3 squared, which is equals to x squared plus 9. Okay, so now we are going to continue with the trigonometry, which is we need to have secant theta, which is going to get from 1 over cos theta. So now we are going to find cos theta first, which is cos theta is adjacent over hypotenuse. Adjacent over hypotenuse would be 3 over x cubed, the square root of x cubed plus 9. And when it comes to secant square, secant theta, which is equal to 1 over cos theta, is equals to x square, the square root of x square plus 9 over 3. Okay, so okay, after the trigo, we're going back to the equation back, which is the 9 secant cube theta minus 27 secant theta. So from here, what we are going to do is we are going to factorize the equation first, which is going to be 9 secant theta. Okay, so in the bracket will be secant square theta minus 3, so plus c. Oh, I'm forgetting the c. Okay, after factorize the equation, now what we're going to do is substitute the secant that we get from the trigo just now, which is this answer, into the equation, which is we're going to put like this way. Okay, s square minus plus 9 over 3 minus 3 plus c. Okay, from here you can cancel out the 3 and 9, so this is going to be 3, this is going to be 1. So now we are going to expand like normally, so this would be 3 times this, and now here we can cancel out after 3 square, so it's going to be 9. Here we can cancel out this square root, so going to be x squared plus 9 minus 3. So minus 3 plus c. So here we're going to make the denominator of this one to become the same. So it would be s plus 9 minus 27 with 9. So plus c. Okay, from here you can cancel out the 9 and 3. So this is going to be 1, this is going to be 3. So in the end, going to get x squared plus 9, and then x cubed plus 9. The positive 9 minus 27 would be negative 18 over 3 plus c. Okay, so we can bring out this 1 over 3. see. Okay, so this is going to be our final answer for this equation. Okay, that's all from us. Thank you.